Okay, so we talked earlier about precipitation. So where does that precipitation go? All right, water that falls on the ground, much of it seeps into the soil, and the water in that soil seeps downward. All right, the water flows in between all the dirt particles, and eventually reaches what we call the zone of saturation. All right, which is an area where water fills all of the open spaces in the sediment and rock. All right. So one way that you can think about the zone of saturation is to think about a glass container containing a lot of sand. All right. So if you took that sand and you poured some water into it, you notice that the water that you pour into the sand is going to seep downward between the sand particles, and it's going to keep on seeping downward between those sand particles until it reaches the bottom of your glass container. All right, at that point, the water can't go anywhere. All right, so it starts to accumulate. And that part of if you left it there for long enough, you'd notice that there's water at the bottom of the container so that you're going to have wet sand there. But on top of that wet sand, you're going to have a region of the sand where there isn't water. All right, so that part of the sand that's got all the water in between all of the sand particles is what you would consider the zone of saturation. And the same thing happens in dirt, all right? Water is going to fall into the soil, and it's going to trickle down in between all these particles here, and it's eventually going to get to the point where it can't go anywhere, all right? So you're going to have a layer of what we call impermeable rock right here, and above that, that water is going to accumulate. So this isn't just water, it's sand or dirt, but it's going to have water in between all those particles. And you're eventually going to get to a point where you've got the dirt and the sand, but you don't have water in between the particles, and that's what's called the zone of aeration. All right. So you'll notice that there's a boundary between the zone of aeration, where there is no water on a normal day, and the zone of saturation, where there is water on a normal day. And what you call that boundary is the water table. All right. One way that this affects us is the ability for us to build a basement. All right, if you've probably heard of people that have basements in their house. Well, one thing about building a basement is that you can't build a basement if the basement would go through the water table. All right, and one thing about the area that we live in is that we have a relatively high water table. All right, which means that you don't have to go very far beneath the surface of the ground before you're going to hit this zone of saturation. All right. So anytime you think about somebody that wants to build a basement, they would have to build a house so that the bottom of the basement would only be in this zone of aeration. Okay. So just one more thing. There's areas of the country. So where is it that we can find houses that have basements? All right. Well, what if this water table is a lot lower, so that you've got a lot more of this zone of aeration to build in? All right. In areas of the country that are like that, it's no big deal to have basements. All right. And you might be wondering, well, what would be the problem if you were to have to build a house with a basement where the basement crept down below the water table? Essentially what would happen is that your house would act like a boat. All right, think what happens if you were to take a model house and you put it into water. It would float like a boat. So if you built a house with a basement that went down like this, all this water would eventually make that house want to float and push up out of the ground. All right. So what is groundwater? Groundwater is just the water that is contained within that zone of saturation. Okay. And again, there's this term water table. Water table is that boundary between the zone of saturation and the zone of aeration. Okay, so how does water move in the ground? All right, groundwater moves by twisting and turning through interconnected small openings. All right, and one thing about that is that it's going to move a lot slower when the spaces between the particles is smaller. All right, and a simple way to think about this is to have a container with sand and have a container with gravel. All right, where would the water be able to get through faster? Would it be able to make it travel through sand faster or through gravel faster? Obviously, it's going to travel through the gravel a lot faster because there's a lot bigger spaces between the gravel particles than there is between the sand particles. So a couple of terms that you need to get used to when talking about groundwater. First of all is porosity. All right, porosity is the percentage of pore spaces. All right, so a quick way to think about porosity would be to think about, like, say, a sponge. All right, when you look at a sponge that's, say, this big, what percentage of that sponge can be used to hold water? All right, and the thing about the sponge is it's got a lot of little holes that can hold water, so it would have very high porosity. All right, compare that to, say, like a chunk of metal. All right, if you put a chunk of metal into water, is that metal going to be able to soak up or hold any of the water? No, there's no spaces between the metal particles that can hold water. Something that would have medium porosity would be something like a piece of wood. All right, even if you don't think of water as being something that can hold wood as being something that can hold water that well, but if you took a wood stick and you put it in water for long enough and then pulled it out, you notice that a lot of the water has seeped into the wood. All right, and that's because it has some amount of porosity. Okay, another term is permeability. All right, so once water gets into a material, how free is it to move around? All right, so let's say, for example, a sponge. All right, if you have a sponge, you've got water in it, but but can that water travel from one part of the sponge to another part? There's some types of materials where the water is able to travel pretty freely, but there's other types of materials where, even though the water is in the pore spaces, the water can't move from one pore space to another pore space very easily. And one thing that's very important for groundwater are these things called aquifers. Aquifers are permeable rock layers or sediments that transmit groundwater freely. One reason that aquifers are very important is that a lot of times farmers will farm on land that is on top of aquifers, and what they can do is they can drill down into that aquifer and essentially suck the water out of that aquifer to use to water their crops. There's a very huge aquifer in the middle of this country, and that's where a lot of the and you'll probably notice that's where a lot of the farmland in this country is.